classify the sequence as arithmetic, geometric, or other. So it's either arithmetic, it's geometric, or it's neither of those. So let's take a look here. Let's see. This is A. Let's do 1, 1/4, 1/9, 1/16. B. 1/3, 1/6, 1/12, 1/24. And C, let's see, 1/6, 1/3, 1/2, 2/3, 5/6. I'm running out of room. Let me move this. Move all of these actually. And I should have comma, dot, dot, dot after each one of these. Oops. Let me write that one again so it's clear. C, 1/6, 1/3, 1/2, 2/3, 5/6, dot, dot, dot. Okay, so first thing they want us to do is classify these as arithmetic, geometric, or other. So what we're going to do is we're just going to look at consecutive terms, and we're going to go through the motions of each one. If it's arithmetic, we should have a common difference. So common difference, let's find out. 1/4 minus 1. That was this term minus the term before it. Is -3/4. If it's arithmetic, the next difference should be the same. Is it? Well, 1/9 minus 1/4. I guess I'll change the color there. 1/9 minus 1/4 is equal to, let's get a common denominator. That's 4/36 minus 9/36 is -5/36. And that's not the same thing as -3/4. So there is no common difference here. So it is not arithmetic. I'm going to have to move these guys. Come on. Down here for later. Is there a common ratio? Let's see. 1/4 divided by 1 is 1/4. 1/9 divided by 1/4 is 4/9, which is not equal to 1/4. So as I take consecutive ratios, I'm not getting the same ratio. So these consecutive ratios are not the same. So this is not geometric either. So our conclusion here is this is some kind of other sequence. Now, that's not to say that you can't find the next term, right? Maybe you can tell me that the next term here is 1 over 25, then 1 over 36, then 1 over 49, and you notice this as being 1 over n squared. So it's 1 over the term position squared, right? This is the first term is 1 over 1 squared, the second term is 1 over 2 squared, and the denominator keeps going up as a perfect square. Anyway, this is neither arithmetic or geometric, but there is a pattern. So, though this is neither, there is still an algebraic pattern. And you might be asked to find those kind of things. Oops. So, anyhow, let's move on to the next example. Let's get started with, is it arithmetic? Arithmetic? Is there a common difference? And all you have to do is subtract consecutive terms. So let's see. 1/6 minus 1/3 is 1 over 6 minus 2 over 6, which is negative 1/6. Then subtracting the next consecutive terms, 1/12 minus 1/6 is equal to 1 over 12 minus 2 over 12, which is negative 1/12. And these are not the same, so there is no common difference. So it is not arithmetic. All right. How about geometric? Is there a common ratio? Well, let's do 1/6. Always the later minus the former, the latter minus the former. 1/6 divided by 1/3 is equal to 1 over 6 times 3 over 1, which is 3 over 6, which is 1/2. All right, that was the first two. Let's do the second two. 1/12 divided by 1/6 is equal to 1 over 12 times 6 over 1, 6 over 12, and aha, we did get 1/2. Is that the same for the other terms? Let's see. Ooh. Third color, let's see. 1 over 24 divided by 1 over 12 is 1 over 24 times 12 over 1, which is 12 over 24, which is also 1/2. Check. Difference, or sorry, common ratio. Of R equals 1/2. So what do we know? Well, our first term is 1/3, and our common ratio is 1/2. This is a geometric sequence. And our nth term is a1 times r to the n minus 1, or here a sub n is 1/3 times 1/2 to the n minus 1 power. And we can double check that just to spot check it here. Let's see. Let's check. A1 is 1/3 times 1/2 to the 1 minus 1, which is 1/3 times 1/2 to the 0, which is 1/3 times 1, which is 1/3. So it worked for that first term. let's spot check another one. Let's check the third one. 1/3 times 1/2 to the 3 minus 1 is 1/2, or sorry, 1/3 times 1/2 squared, which is 1/3 times 1/4, which is 1/12. Check, as that is our third term. So seems to be working out. Okay, so it was in fact geometric. Example 8C, the directions were: classify the sequence as arithmetic, geometric, or other. So here we'll start off again the exact same way. Let's find a common difference, if it exists. Please note that I'm going through this in a systematic way. I'm hardly even looking at the sequence. I'm not trying to guess ahead of time what's going on. This one is especially confusing because it doesn't seem to have a discernible pattern. But if we just go through the arithmetic here, we'll see that our 1/3 minus 1/6 is 2/6 minus 1/6, which is a sixth. And then that was for our first consecutive, so that's plus 1/6. For our second consecutive, or common difference, we have 1/2 minus 1/3, which is 3/6 minus 2/6, which is also 1/6. It's looking good for us. Let's try one more here. For our next common difference, we have 2/3 minus 1/2, which is 4/6 minus 3/6, which is 1/6. And again, as I said before, simplification is the enemy of pattern finding, and this probably would have been a bit more clear if we'd have just written this as 1/6, 2/6, 3/6, 4/6, 5/6, and then you could probably tell me what the next one is without hesitation. 6/6, or 1 would have been the next term there. And this continues. And so each time we're adding a sixth, we have d equal to 1/6 as our common difference. This implies that this is arithmetic. And our general form for an arithmetic sequence is a sub n is equal to the first term plus n minus 1 times the common difference, which happens to be 1/6, excuse me, 1/6 plus n minus 1 times 1/6. And if we simplify that at all, this is 1/6 plus n/6 minus 1/6, which simplifies to just be n/6, or 1/6 times n, is our general form here.